What makes something strong? Is it just about being big and heavy, or is there more to the story? On Mythbusters, we know it's not just about size. Sometimes the smallest part can be the most crucial. A truly strong gear is a marvel of engineering, built to handle massive forces, torque, and pressure without failing. It's not just about brute strength, but about how well it can do its job day after day without giving in. It's about the material, the precision of its teeth, and its ability to work flawlessly under extreme conditions. Every tiny detail matters, from the way the teeth are cut to the type of metal or composite used. These gears power everything from race cars to Mars rovers. They're the hidden heroes inside machines that push the limits of speed, endurance, and exploration. Torque is the twisting force that makes things turn, and a strong gear must handle it without losing its teeth. If a gear fails, the whole machine can come to a grinding halt. The pressure at the contact points is immense, like balancing a skyscraper on a pin. Every rotation is a test of strength and precision. Friction, heat, and constant stress are relentless enemies. Over time, these forces can wear down even the toughest materials, so gears must be designed to resist them. The strongest gears are not just metal, they're precision instruments designed to endure. Engineers use advanced alloys, heat treatments, and coatings to make sure these gears last as long as possible. Environments matter. Race cars face heat and speed, where every millisecond counts and failure isn't an option. Mining trucks face dust and grinding work, operating in some of the harshest, dirtiest places on Earth. Mars rovers face vacuum and radiation, surviving years on a planet millions of miles away with no chance for repairs. Strength means reliability when it matters most. When lives, missions, or millions of dollars are on the line, gears can't afford to fail. We're not just looking for the biggest gear, we're searching for what true strength means. It's a combination of smart design, the right materials, and flawless execution. It's power, precision, and endurance, where design meets material science. Every gear is a story of innovation and problem solving. The strongest gears transfer all the power an engine can give, smoothly and reliably, turning raw energy into controlled motion. Whether it's winning a race, moving a mountain, or exploring Mars, it all comes down to these amazing, toothed wheels. Unsung champions that keep our world moving forward. Let's take a closer look at the gears inside your family car, a marvel of everyday engineering that most of us rarely think about. Now, let's compare those to the massive gears found in extreme machines, where the demands are on a completely different scale. Car gears are designed for comfort, smoothness, and long-term reliability. They're made from toughened steel and live their entire lives protected inside a sealed casing, shielded from dirt, moisture, and the outside world. Their greatest strength is their quiet consistency, working day after day, year after year, often for hundreds of thousands of miles without complaint. But step into the world of extreme machines, and everything changes. Here, the environment is harsh, the loads are immense, and the stakes are much higher. Formula One cars and mining haulers face forces that push the limits of physics, where a single failure can mean disaster, lost races, or even millions in downtime. That's why high-performance gears are crafted from exotic alloys, titanium, or even ceramics, and rely on specialized lubricants to survive the heat and stress. In these machines, comfort and quietness are sacrificed. Here it's all about raw performance, speed, and surviving the most brutal conditions imaginable. Every component is engineered to the absolute limit. Lightweight, incredibly strong, and able to withstand relentless punishment from both the environment and the machine itself. Think of car gears as marathon runners, steady, reliable, and built for endurance. Extreme machine gears, on the other hand, are like sprinters, designed for explosive bursts of power in a high-stakes race. Both types of gears transfer power, but they exist in completely different universes, each with its own unique challenges and demands. Understanding this difference helps us appreciate the incredible engineering and innovation that goes into machines operating at the very edge of what's possible. It's a beautiful demonstration of how a simple concept, two gears meshing, can be pushed to astonishing extremes, adapting to every need. That's the true art of gear design, blending science, creativity, and precision to meet the demands of any world. For gear technology at its limit, look at the Koenigsegg Jesko Absolute. Its light-speed transmission, LST, is a 9-speed multi-clutch marvel built for one thing: top speed. Unlike traditional gearboxes, the LST can jump between any two gears instantly, no sequential shifting required. Multiple clutches open and close the exact ratios needed, giving the driver instant access to peak power. The gears are crafted from high-strength Swedish steel, finished to watchmaker-level precision. Despite its complexity, the entire transmission weighs just 90 kilograms. These gears must handle 1,600 horsepower and face-melting torque at over 300 miles per hour. Failure is not an option. The LST proves strength isn't just brute force, it's intelligence, speed, and flawless execution. When existing technology isn't enough, you invent the future. That's the Koenigsegg way. Now, from racetracks to open-pit mines, let's explore a world where raw power and endurance are everything. In mining, strength isn't just about speed, it's about relentless torque, the ability to keep moving under unimaginable weight day after day. Machines like the Caterpillar 797F haul truck are true giants, capable of moving over 400 tons of earth and rock in a single load, enough to fill dozens of pickup trucks at once. At the heart of these machines are planetary gear sets, which multiply engine torque and distribute these massive forces across multiple gears. These gears are enormous, several feet wide, weighing hundreds of pounds each, and forged from specialized steel alloys designed to withstand the harshest conditions on Earth. Every day, these gears endure brutal shock loads, clouds of abrasive dust, and extreme temperatures, working around the clock, 24/7. Housed in heavy-duty casings, they're constantly bathed in specialized lubricants that cool, clean, and protect every moving part, ensuring smooth operation even under the toughest conditions. When a gear fails, it's not just a minor setback, it's an economic disaster that can halt an entire mining operation. A single mining truck can cost millions of dollars, and every hour of downtime means lost productivity and revenue. That's why mining gears are engineered for maximum durability and reliability, operating for tens of thousands of hours without fail, often in some of the most remote and unforgiving places on the planet. These gears are the silent heart of the mining industry, working tirelessly behind the scenes, moving mountains and shifting tons of earth and ore every single day, making modern mining possible. Their true strength isn't measured in speed, but in their incredible endurance and ability to keep going year after year. These gears are the unsung heroes of our modern world, enabling the extraction of the resources that build our cities and power our lives. In the end, they measure strength not in miles per hour, but in mountains moved and challenges overcome. On the battlefield, gear failure isn't an option, it's life or death. The M1 Abrams tank's transmission harnesses 1,500 horsepower and delivers it to the tracks with absolute reliability. Its Allison X 1103B hydrokinetic transmission combines automatic shifting and hydrostatic steering, allowing maneuvers like pivoting in place. The gears withstand shock, vibration, and immense torque, built from vacuum-melted steel alloys and tested to military specs. Every gear is inspected for hidden flaws. Indestructibility is the goal. The sealed transmission protects against sand, mud, and cold. Survivability defines these gears. Failure in combat means disaster. Every component is over-engineered for toughness and redundancy. These gears don't just move a machine, they protect lives. They're the hidden muscle behind the tank's power and agility. Now, to the most extreme environment, space. Mars rover gears face challenges unlike any on Earth: precision, endurance, and zero chance of repair. Temperatures swing from warm to minus 100 degrees Celsius, normal metals would shatter, and standard lubricants freeze. NASA uses exotic materials, special steel alloys, titanium, even bulk metallic glass. Lubrication is a challenge. In near vacuum, liquid lubricants evaporate, so dry films like molybdenum disulfide are used. Some parts run with no lubricant, relying on material properties alone. Every movement is slow and deliberate to minimize wear over years. Radiation in space degrades materials, so everything is radiation hardened. The strength of a space gear is resilience, working perfectly after a 9-month journey, then for years on Mars. Small, slow, but among the strongest things we've ever built. These gears are the quiet champions of interplanetary exploration. From space to sea, the gears in container ships and warships are true giants. Main reduction gears can be over 20 feet wide, weighing more than a house. Their job convert high-speed engine rotation into the slow, powerful turn of a massive propeller. The forces are staggering, tens of thousands of horsepower non-stop for weeks at sea. Gear teeth are huge, cut and polished for perfect precision. They live in sealed cases, bathed in thousands of gallons of oil, constantly filtered and cooled. The gear system is mounted on a rigid foundation to prevent misalignment. Failure at sea is catastrophic. Repairs are costly and slow. Marine gears are built for decades of service, combining brute force with precision. They are the beating hearts of global commerce and naval power. Back to the racetrack, Formula One, where strength means speed, lightness, and heat management. F1 gearboxes endure forces beyond belief, with seamless shift systems that engage two gears at once for uninterrupted power. Shifts happen in 20, 30 milliseconds, faster than a blink. Gears are made from specialized steel or titanium, forged and machined to submicron tolerances. Heat is a constant threat, so gearboxes double as heat sinks and use advanced oils. Each gearbox lasts only a few races before a rebuild. Gear teeth can deform and wear out in hours. F1 gears sacrifice longevity for ultimate performance. Here, strength is measured in milliseconds and grams. The difference between winning and losing is found in microscopic perfection. This is engineering at the edge of possibility. So, what's the world's strongest gear? There's no single answer. The strongest gear is the one perfectly designed for its unique challenge. Mining gears move mountains. F1 gears handle insane power in milliseconds. Each is a champion in its own arena. Some are built for ultimate reliability, like those in tanks or Mars rovers. Marine gears endure decades at sea. All share one principle: failure is not an option. These gears represent the pinnacle of human ingenuity. They're the unsung heroes inside the machines that push our limits. Which would you want to see in action? The silent Mars rover, the roaring F1 car, or the earth-shaking hauler? The story of engineering continues.